Power's just kicked off a digital transformation to change the way that we run IT. Looking for more flexible architectures and driving digital development of digital and data products for our energy solutions business. And we've decided that DevOps as an operating model is core to that digital transformation, and we need to learn a lot about that, rather than sort of tell everyone in the team how you should do DevOps, because I don't think DevOps really works that way. It's not supposed to be prescriptive like that. We decided to bring the whole team, so there's I think 50 people from Perth, Brisbane and Melbourne here to learn for themselves and get the opportunity to bring new ideas back into the organisation and experiment and get better at what we do. So the best precedent, because for where we are in the journey of implementing DevOps practices at ERM, learning from other companies and what they've done and their experiences is probably most relevant for us at the moment. So the ones that have been good were the SRE conversation from Google and how they run that site reliability engineering within Google itself. The talk from ING Bank and their journey through SREs as well. And the the talk from Message Media around how to, I call it eating the elephant, but slowly picking apart legacy architecture and implement microservices is really valuable as well.
Thanks for coming. Yes, that long laundry list just looks like I don't specialize, and I don't. So there you go. But for the beginning, how many people here are devs? Cool. How many are ops? Yay, ops. And how many are DevOps? Wait, did you put your hand up for both? Yeah, hope so. That's very good. Excellent. Who's not DevOps or DevOps? Oh, there's a couple. Okay. What do you do? Consultant. Okay, that's kind of DevOps. Anyway, last year I was presenting here and I had 76 slides in 45 minutes, and I promised Igor I would improve this year, so I've now got 84 slides in 45 minutes, and I've just wasted a lot of time. So moving right on, I want to remind people about what I said last year, and it's really the topic of this talk, the entire talk. I don't like the term serverless. I don't like the term NoOps. I realize my company talks about these terms. Please forgive me, my company, do not sack me. But I believe in scalable ops. I think there's no way of getting around ops no matter what you do. So let's talk a little bit about scalable ops. I put this slide up last year as well. The further you move up the tech stack, the further you move away from dedicated metal, up to virtual machines, containers, PaaS, SaaS, or functions, you're really reducing the load on your coding team. And that's operations code, and that is also dev code. So there is benefit to moving up. So last year I talked all about containers and Kubernetes, so I've decided to take a leaf out of my own book and move up. So this is going to be above and beyond Kubernetes, so you can imagine, all right, so if I don't want to believe all this, serverless and NoOps stuff, what if I just imagine that's going to go into a container and you can comfort yourself that way? If you don't like Google products for whatever reason, just imagine the competitor product set, and hopefully it does that. Okay, so no apologies beyond that. So what I'm going to do is I'm going to build an application. So I'm going to introduce what that application is. We're going to go through the planning process, the trade-offs, the high-level architecture. We're going to do some architectural deep dives into product selection. And we're going to do that all in 45 minutes. So the product is product now. I want my product now. We're going to work for an existing online retailer. They've got a large product catalog, a large volume of transactions, and they want to allow sort of a marketplace capability as well. So they want to let their consumers put stuff up to sell in their marketplace as well. And they're looking to move to a new way of selling. So they've sort of created this team, which we'll get to in a minute, and they've been given complete autonomy to choose whatever tools they want. It's sort of like startup within an enterprise. And so the rules they've been given, or the bounding box they've been given, is they need to minimize operational complexity. They need to prioritize time to market. They want it yesterday, like all management. They want continuous delivery. So they want to see forward progress all the time. and they want to leverage the existing product catalog and data set with as little impact on the enterprise as possible. So not much. They want mobile first and chat experience. Leo's already gone there, which is very good. They want machine learning for recommendation engine in there. They want it to be fully conversational, and they want it to be globally available. So not much. What do we get? We get 20 devs. They're basically borrowed from other teams, so that's a complete mix of polyglot skills. So we've got Node, Go, Java, Python. Luckily, we have a Python person who studied ML at university, so maybe they'll do our recommendation engine for us. And we've got a couple of people who have worked as DevOps, maybe a consultants come in from the side of stage to work on this as well. But you've got 20 people to do this with. So key decisions. Well, the first one is my favorite topic, which is architecture. Right? So there's a lot you can get wrong if you don't think about architecture up front. But I'm a big believer in the fact that architecture should be expedient. Architecture should allow you to move, and you don't sort of write architecture once and never revisit it, which is how some people think about this. But I think you do have to think about it up front, otherwise you end up in this God damn it, never mind kind of position, right? So there's another thing I'm a big believer in is Conway's Law. He was a software programmer consultant in the mid-60s, so this is that old, this law. But essentially he said organizations, the communication structures in the organization pretty much define what your architecture is going to be. So if you work for a big enterprise, you're already screwed, right? So in essence, if you build a new system and that's your organization structure on the right, your architecture will emulate your organization structure or your communication guidelines. Who here has recently embarked on a digital transformation? Your architecture is now your enemy. Because you've changed your org structure, but your architecture is the old org structure. So now every single part of your existing legacy infrastructure is now fighting you tooth and nail to resist change, according to Conway's Law. And you'll feel it, and you'll know, that guy was right. That guy in the 60s. So we got this structure in our organization. So even though we've been given carte blanche, we've still got kind of reporting lines we've got to go back to and be honest to. So there's a web lead, a data lead, and a DevOps lead. And so we're going to have jurisdictions of control and expertise around that, which means our architecture is going to look like this, pretty much. So we're going straight for the organizational role of architecture. So the serving infrastructure team will be in charge of chatbot, web, mobile. The tooling people will be, DevOps people will be in charge of CI/CD, monitoring, logging, SecOps. The data processing team will be in charge of analytics and the recommendation engine. So we're going to look at some technical choices. Again, we've been given carte blanche to use anything in the world we want, so we've chosen to use all Google software. Yay, for the win. So we've got some serving choices there, we have some data storage choices there, we have some data processing choices there, and we have some data tooling stuff there. You'll notice in the tooling side, some of that is not Google-owned stuff. But I do want to bring it up as well, because there's some cool stuff in there as well. So I'll go into that in detail, so we won't drill into it now. This is what the final architecture is going to look like, but I'm going to give you the logic behind this. You're going to notice that pretty much, if you know Google products, pretty much everything there is either SaaS or PaaS. There's absolutely no infrastructure as a service in that diagram whatsoever. I'm not going to be patching any machines. I'm not going to be working on any infrastructure. I'm not going to be installing any virtual machines in this side of things. So the serving infrastructure first. So let's go chatbot, web, mobile, serving infrastructure. So we have some trade-off conversations to look at. So the choices we have here, number one, we could put it on App Engine Standard. So App Engine Standard, it's fast, it works really, really well, especially if you want to work inside Google. It scales from 0 up and down. So there's a Good Friday appeal here in Melbourne. It's based on App Engine Standard. So it basically doesn't exist until somebody starts using the donations page once a year, and then it ramps up for 14 hours and goes away again. It was written 5 years ago, and it hasn't been touched since. Right? All it does is ramp up, pay a bill, except somebody pays that for them, and then it ramps back down again. And that's really, if that's what you want to do, and you've got a really patchy kind of performance system, App Engine Standard is great. App Engine Flex I really, really like. You can just dump a container in it. Problem is it doesn't currently scale back to 0. So you've got a question there about how you manually control the scale back down if you want to have the scale back down. It's less opinionated than App Engine Standard, and a wider range of programming languages. Cloud functions. It's unfortunately, it's been in beta for about 2 years, so that means it's stable, but we don't want to put it into production. I don't know. The pros is it's serverless. It scales to 0. It's opinionated. It's JavaScript only, but that's okay because pretty much everyone has JavaScript skills. Probably the only really nagging thing is Express.js. Otherwise, say no if you have a choice. The other choice, which is quite interesting here, is Firebase hosting. So essentially, if we were talking about a static-only site, we could basically dump into Firebase hosting. We'd get free HTTPS and certificate rotation, free global CDN, almost 0 cost unless we're really going to hammer this. But the con is really it's just for static content. So the winner here, surprisingly, is Firebase hosting, because we're going to do some tricky stuff. So how do we vary the content? Well, we can use the same trick we use in an iOS or Android application, which is client-side rendering. So that gives us rich interactions without reloading the page. It's a little bit slower, but once it's loaded, it'll be faster. It works with statically hosted content. And perhaps the only downside, despite where I work, is there's an impact on search engine optimization, because you've got content that's not sort of linked and indexed because it's dynamically rendering. So what are the trade-offs? For the client side, we could build, to have this static content talk to something, we could have it talk to an API. Now, the thing about an API is it's basically an abstraction layer, usually over a data source, and in our case, that's all it's going to be. I don't know how many people are really interested in databases and APIs, but really it sounds like I'm going to be doing a whole bunch of work to replicate an existing RESTful call directly onto a database. So I could just use the Firebase real-time database. So the benefit there works out of the box. I only have to write, I just have to write my app code. I don't have to write an API at all. Scalability is a little bit limited. We recently announced it is in beta. Firestore works out of the box. This is basically Data Store, the Google Data Store product available to Firebase. So scales to around, I think, 10 terabytes of data to be stored. So this is going to be our choice. We're going to use Cloud Firestore. So then we need to look at cross-platform. This also, when we start using Firebase, we get all these cross-platform SDKs, so we can talk to iOS, Android, and many more platforms. All of these work with the Firebase backend, which gives us a whole bunch of other services in there, which I'll discuss a little later on. A couple of things that we get that are free with this is we get the real-time data interaction. So if one user writes something like a chat message into the system, it gets replicated to all of the appropriate, security qualified target systems. So that's really cool. We also get effortless offline persistence. So if somebody goes in through the domain tunnel and they lose their internet access, they're in the back of a cab or they're in a driverless car, they can do keep using their app, and as soon as it comes back out, regains connectivity, the browser cache will synchronize that. So what about our chatbot? Well, in reality, we have this thing called the Firebase admin SDK, which gives us a sort of a server-side capability. So we could have the chatbot talk just like any other client to that admin SDK, but we're going to have to put a little bit of glue in there because the admin SDK doesn't see the real-time database signal, so we're going to have it trigger off something like a cloud function to get that to work. So this is sort of what our architecture looks like by the end. So you have your browser, you have your web application, you have a browser cache for offline mode, you have global CDN, content delivery network, to your static content, and then you have API calls directly into Firestore to get your real-time data. You have the admin SDK listening to an event function, a cloud function, which is talking to PubSub, which will force any real-time events down onto the admin SDK that can allow it to run a chatbot back into the system. And then you can send all your clickstream analytics straight out via another function and PubSub. You can also use Cloud Function to trigger cloud messaging to send push notifications into the clients. Now, you can do that easily on Android. The Android browser supports service workers, but not on iOS. So what we'll do is we'll probably build a native iOS app rather than have a fully browser-based experience if we want the push notifications on iOS. And look, we might build a native Android app if we want to do that as well, but don't need to at the end of the day. Now, for added chatbot goodness, rather than just have a chatbot that's replying with some set answers from the database, we can actually hook it all into a Dialogflow. And Dialogflow gives us access to not only Android and Google Home from a voice interface, but that's also an SDK that can be embedded in all sorts of weird hardware like the Google Cocktail Mixer. But it also speaks to Facebook, Slack, Cisco, Alexa, Skype, Cortana, Viber. So you're getting a whole lot of goodness for sort of one piece of chatbot code. So we can build that into the infrastructure as well. So what we've got there is we've managed to build a progressive web application, offline enabled, responsive, re-engageable. So it's got push notifications for catching up with people who don't buy things or if you just like serving ads. It's installable, it's linkable. So pretty cool, right? And all at a sort of I hate the term, serverless sort of layer. And we've used the Firebase hosting and the Firestore to basically serve up the content through a global CDN, as well as provide that capability for dynamic content on the outside. And again, lots of cloud functions triggering to messaging queues, triggering to other systems. So how do we do the data processing? Well, data processing, we've got two problems. We've got batch and we've got streaming. Number one is how do we move our product catalog from on-prem, product catalog and image catalog from on-prem into the Firestore system so we're not putting a massive load back on the enterprise? And how do we then keep that in sync? Because remember, we were going to have people add content into this as well, and we want to sync that back. And also, we might want to send interactions, at least curated interactions, back into the enterprise as well. And we want a recommendation engine for machine learning. So essentially, we're going to use a micro-batch and sync strategy. So we're going to do a batch data drop-offs, and then we're going to do some processing, and where we see new events, we're going to send that back into the enterprise. So we just need sort of two communication channels out of the enterprise into our platform. And then we're going to have this online database over the top. So we've got a few choices for online database. For the data drop-off, we can use a filer. People like filers. It looks like folders. We all like looking at folders. Not really, really practical. It doesn't scale brilliantly, and it's always on, and you've got to pay for it all the time. And again, I said I wasn't going to use any VMs in this architecture, so I hate that. Second thing is I could use Cloud SQL. So we have MySQL and Postgres. But again, scaling complexity, there is some scaling complexity in any sort of SQL there, and it is always on, and it is always build, and it smells like infrastructure to me. So let's just get rid of that. And so the other option is actually just cloud storage. It's an object store. So it has high throughput, has some lifecycle management. If you like POSIX, you won't like it. And then finally, what's the last one? Yes, there's sometimes issues with object consistency. So if you know, it's not great for things that have to be consistent in near real time. But again, we've got a product catalog, not super important for that consistency point of view. So then the solution trade-offs for the data processing, we've got a few options. We can run up a massive Hadoop cluster. Again, don't like it. Scaling difficulty, always on, always build. Data flow is essentially really good for things we're going to be doing, which is sort of batch processing and time series or clickstream processing. So I kind of like this. I'll be leaning towards that. It's a new programming concept to most people who know Hadoop. It's platform as a service. You write Python or Java code to do transformations of data merging, ETL essentially, and time series, time windowing calculations. And then the final one is Dataproc, which is essentially hosted Hadoop. So again, it's good. It'll turn on when I need it. It'll turn off when I don't need it. But I'm going to go with Dataflow because the windowing of the clickstream analysis is going to be important. And actually, Hadoop sucks at that. So we're going to use Dataflow, which is essentially Apache Beam. So now we're going to look at the stream processing. So how do we take the clickstream data, feed it down into the system for machine learning and recommendation engine? So we've got a couple of choices here. We could use Kafka and GCE. Again, I don't want to have a VM, so I'm not excited about that. Kafka is cool. We've got about, I think we've got some Google devs working on Kafka, about 10 of them at the moment. So that's kind of cool. PubSub, however, is software as a service, essentially. basically fully scalable, global, REST API. The problem it has is it's got no ordering of events. But that's okay, Dataflow can fix ordering of events, so combined with Dataflow, that's not a problem. On the other side, yes, we've got Dataflow to correct the order of events, or we could use Dataproc, but as I said before, it smells like infrastructure to me. So we're going to choose Cloud PubSub and Cloud Dataflow. And so our data processing pipeline, batch and streaming, starts to look like this. We're going to have the listing data and the interactions come through to PubSub. Dataflow will read it off, reorganize it. If it's anything that needs to go back to the data warehouse, it'll into the micro update. Otherwise, straight out to the clickstream analysis for machine learning. So now let's get on to recommendation engine. 17 minutes left. Haven't even got to tooling yet. So we've got a choice. We can do content-based, which is to select the most popular products. We can do collaborative filtering, which is a combination of behavior and pattern-based, or we can just ask users for preferences, and users lie, so we're going to do the behavior and pattern-based approach. So in this one, the wisdom of the crowd says weighted alternating least squares, which is essentially you have all of the people on one axis of your matrix, and you have the frequency of interaction or what they've bought on the other axis, and you just do a nice bit of matrixy mathematics. Thankfully, it works really, really well with TensorFlow, our open source AI code. So we have a choice here. We could run TensorFlow in a VM. We're not going to do that. We can run TensorFlow as a managed service on CloudML, which is probably where we're erring towards. And then once we've trained our model in CloudML, we want to serve it. So once you train a model, it's essentially put data in, I get answer out. So it's basically an API. So what I want to do is probably host that API in something. So I can host that either inside an App Engine or Cloud Machine Learning. Now, actually, App Engine is going to be more auto-scalable and cheaper. So we're going to choose machine learning to train, but App Engine to serve the model. Incidentally, once you train a model, you can serve it on your own infrastructure. You can serve it on a phone. So there's TensorFlow Lite for Android phones. So literally where you serve a model is irrelevant to where you train it. You can train it on secure hardware over a secure environment. So you can serve it over insecure hardware over a secure environment, even if you train it on the cloud, or vice versa. You could train it in a secure environment and run it in a public ecosystem. So we're going to take the listing data and the interactions. We're going to actually use Dataproc. I can't get away from this because Hadoop is a Swiss Army knife. Dataflow is a scalpel. So Hadoop can do more things than Dataflow can, and I'm going to use this for doing certain amounts of batch processing, but I'm only going to do it a little bit, not for the whole time. So we don't have to worry too much about that. It's going to drop the models and data into cloud storage, which is essentially going to be reading from Cloud Machine Learning or from App Engine. So that's our machine learning and data processing flow and architecture. Sorry, you want to take a picture? There you go. It's good. I like it when people take a picture. Cool. So tooling. Okay, so we're going to do CI, CD, and CD. It's OCDC, I think. So essentially, continuous integration is just making sure that that what management doesn't want to see is we've got code sitting on our laptops for 3 months that we're tooling with and we're not putting back into some sort of secure system and it's not building against everyone else's. So CI is vital. Continuous delivery is, we want to show forward progress all the time, and we want to make sure that it's going to work with everything else. And then continuous deployment is, I want to check my code into that thing there, and stuff happens, the release train goes out, and I stop thinking about it. So there's I think this comes from a book somewhere. I should reference it. But in any case, CI does the top part, CD does the bottom part. There's lots of steps. You can see CD is more complicated than CI. Parts of CI can be taken into CD. There are tools that do CI and CD, and they kind of have jurisdictions. There's sort of 3 parts to this. You've sort of got the build, execution, and artifact creation. You've got the pipeline orchestration, and you've got the deployment. No one tool does everything, so you're going to have to work with a couple of different tools to solve this problem if you want to do all of CI and CD. But pretty much everything up there is good. So let's look at the 2 tools I'm going to kind of trade off against one another. One's Container Builder. So Container Builder was specifically designed to build containers for Google Kubernetes engine. So if you're doing any Kubernetes work, do have a look at Container Builder. It can do everything Docker Build can do. It can do a little bit more in terms of CI tasks. And so And it can do some really, 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 really limited CD, but that may be just enough for us. And it can also not just create containers, but it can shift artifacts into Google Cloud Storage, which is kind of what we're looking to do. A container into App Engine Flex, which is the model we're serving, and some stuff into Google Cloud Storage. So that's probably all we need from CD for the time being. The other one is Spinnaker. Spinnaker is really cool. You should have a look at it. It's essentially designed for complex deployment pipelines. So where you're going to branch and look at multiple different things. So if you're getting into it, how do we do better test automation? Do have a look at Spinnaker. It can do a lot of very cool stuff. And it's got loads of integrations, like tons and tons and tons of integrations into not just Google stuff, but lots of other products as well. So Spinnaker, very worthwhile looking at monitoring as well, which is kind of important. From what we saw from Elizabeth's Puppet demo earlier, your pipeline is probably going to be a problem from cybercrime. So the trade-offs here, we're going to choose Container Builder, we're going to choose Spinnaker. To cut a long story short, Container Builder is going to be simple enough, so we're going to choose it for now. We can always retool onto Spinnaker later on when we want to get more complicated. So this is sort of what our CI/CD or Container Builder flow looks like. We're going to pick up some of our source code and our source files. We're going to run through some build steps, and we're going to dump stuff into a container registry and into Google Cloud Storage. Now, logging and monitoring. So we have some choices here. Both of the products on the right, Datadog and Splunk, are excellent products, but one does monitoring and one does logging, and I don't want two tools, so I'm going to choose Stackdriver. And pretty much Stackdriver, because I'm doing everything on Google already, Stackdriver is going to be part of a solution for Splunk anyway, so it's just the most expedient choice to choose Stackdriver in that place. If you haven't had a look at Stackdriver and you're doing anything on Google, do have a look at Stackdriver. It's very, very cool. Now I need to look at IAM, identity, two-factor authentication, all that sort of stuff. So I've got options there. I can use my on-prem LDAP, which is I control the identity of the users. I kind of like that. I can use Google authentication or some other form of internet authentication, although it's less popular as of a couple of days ago. I can use SSO, so Okta ping, that sort of stuff. And so I'm going to lean towards the LDAP because I want to own the identity of my users, and that can easily be synced into the Google ecosystem as well, which means I control the master and then everyone runs off that. Deployment, I've got some options there. Deployment Manager, Terraform, or manual scripting. Manual scripting, just say no. Terraform, awesome if you're doing multi-cloud and on-prem. Deployment Manager does an awesome job if pretty much everything you're doing is on Google. The only problem with using Terraform for Google stuff is it will lag. So essentially it's one of these connector products, so it lags the capabilities while their teams go and do dev to make it all glue in together. So you're always waiting to get features. So recommendation is Deployment Manager. The last thing I need for 10 minutes to go, my God, I'm doing well. So long as you're all following it and not falling asleep. Right? The last thing I need is I want a bit more on security. So Google's just open sourced a while ago, actually, Forseti. Has anyone used Forseti or read up about it? So what Forseti does is you give people a whole bunch of privileges to do stuff in the cloud. And along with doing that, you teach them a whole bunch of best practices, like, you know, don't open up your firewall to 0.0.0/0, right? Don't allow people from, don't assign people from outside a domain to do X. Don't create things without two-factor authentication. Never run this in concert with that. And of course, they ignore you, right? Which is what SecOps is all about. So what we can do is we can actually crawl across all of the projects and look at all the entities, and we can scan the policies we've set, and we can see who's in breach of the policies. And then we can decide what action needs to be taken. And in some cases, we can actually enforce changes. So at the moment, I think Forseti in the open source version only does firewall enforcing. That's a good thing, as you saw from Elizabeth's talk earlier. So if you have an automated bot going around your entire cloud deployment going bad, enforce, bad, enforce. Inside Google, we have something called the GCE enforcer that comes around and hammers all of our demos when we do bad things. So it's this kind of, you're going to give people freedom, they're going to do the wrong thing, you need some sort of security solution to fix that up. Your other options are custom tooling, which is a pain, or no tooling, which is atrocious. So the recommendation here is go have a look at Forseti. Right? If you're doing anything on Google, have a look at Forseti. If you're not doing anything on Google, have a look at Forseti. It's open source. Right? Work out how you can make it work for what you want to do. A lot of the framework for what you're trying to do is already there. But having tools that automatically look at these policies and scan and enforce them is important. So I want to talk to you about one thing that we joked about at the dinner on Wednesday night, which is we've got NoOps. Why don't we have NoDev? Hands up who likes NoDev. So I put in these slides in here. So this is NoDev. So Google is an AI-first company, which means if we're going to build a new product, we first think about what the AI is going to be for that product. We don't go straight to mobile. So mobile is second. AI is first. So we do AI, then chatbot, then maybe we'll do a mobile interface, right? And then maybe we'll do a mobile web interface, and then maybe we'll do a desktop interface. But you can see there, we had the strategy long before we announced it. You can see the spike in AI projects. So just last quarter of last year, we had almost 7,500. We'll be over 7,500 AI projects active in Google at the moment. These are serious projects. So the problem we've got is there's not enough AI talent in the world to run all these projects. And if we keep hiring all the AI people, what are our customers? Who are our customers going to hire? So there's a massive problem there. So fortunately, we have a lot of AI programmers. So we said to them, you know, I know you're supposed to be automating everyone else's jobs and then turning the lights out, but could you start with your job? So just automate your job first, because it's a problem. So AI is actually a complicated thing. This is what most people think AI is. This is what most managers think AI is. You take lots of data, there's some complicated maths you don't understand, and then you get a magical shining stag on a mountaintop. That is not what AI and machine learning is like. It is thoroughly painful, manual, arduous, and you go and you explore families of node structures, and you do hyperparameter tuning, and you get various people's different forms of starting APIs, and you say, well, if I do transfer learning on this model, how does it perform versus this model? And you know what? This is something AI is actually really, really good at. So you can actually get an AI to go and explore thousands of families of nodes, do thousands of combinations of parameter tunings, play with all sorts of where do I cut the transfer learning off the old model. And so we've built this thing called AutoML. So essentially, it sits in between the predefined APIs we have for things like vision, data loss prevention, natural language processing, speech-to-text translation, and the hardcore manual coding side of things. So if you're just an analyst, you don't want to understand how to use Python, and you know nothing about TensorFlow, all you have to do is classify your data, push it into the bucket, and turn the machine on, and it will write the code for you. So I give you NoDev. So we've released a Cloud AutoML Vision being used by companies like Disney and many, many others. But Disney's willing to let me say their name on stage. And so this is essentially looking through all of their image and cataloging and tagging, automatically tagging all their products. So it's a custom Vision API. It's not the Google Vision API. It's the Disney Vision API. Right? You can use it for classifying car models, flower types. You can look for copyright infringement in images. You can use it for all sorts of other security images capabilities as well. In addition to AutoML, we are very, very close to things like recommendation engine, custom recommendation engine, custom natural language processing, custom object detection, all these sorts of things. So almost everything you can think of doing with an ML that has a pre-existing model, AutoML will do for you, which massively democratizes and scales the capability for every company to have an AI-first strategy if they want. Now, I promised someone at the back that I would talk about self-driving vehicles. Now, I talked about the self-driving car last year, and I don't want to repeat myself, so I'm going to talk about self-driving balloons. So this is the Google Loon project. So Google Loon is trying to deliver internet connectivity to poor areas of connectivity around the planet, but it is actually kind of morphed into a disaster relief internet capability. So we can launch balloons from Puerto Rico in the Caribbean and give them a GPS location, and they will auto-navigate using the stratospheric winds. So they'll move up and down and essentially flock down to Peru during the Peruvian floods, and then hang there for about 100 days and provide internet coverage while the internet is reestablished in the flood zones. And now those balloons are flying over Puerto Rico because of the hurricane that wiped out Puerto Rico. So that's the self-driving balloon. The second one is the self-driving drone. So this is Project Wing. This is being tested in Australia on the New South Wales-Canberra border, or ACT border. And it's being tested in Australia because, I quote, of Australia's relaxed civil aviation laws. Anyone who's ever done anything with Australia's civil aviation laws knows they're not relaxed, but obviously they're more relaxed than other places. So this is actually a design that has had a lot of AI input into it. It doesn't look like any plane a human being would design. It can travel 140 kilometers an hour, has a 10-kilometer range, and has a 1.5 kilo lift capacity. Doesn't land, it's self-navigating. It only lands to recharge. So it actually drops a line to release the package and pick up a package. So you can go see videos of this online. Just go Google Guzman and Gomez, or Guzman y Gomez burrito deliveries. We're doing great things with this stuff. Have a look at Next 2018. It's coming up in July in San Francisco. Buy yourself a ticket, have a holiday, come see a lot more Google magic. I couldn't cover it all on stage today. Serverless, NoOps, they're just crap terms. There are ops, there are servers, but you can make use of the technology to do very, 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 very clever things. You're just never going to get rid of ops. So stop trying. It's all about scalable ops. And if you're an ops, you need to understand this. There is definitely ops involved in all of this, and it's really important that we stay engaged in this stuff. Move up the stack. If you're thinking about Kubernetes, look beyond. I was on stage recently, and one of the managers said, look, you got us retooling everything into Kubernetes. A while ago, it was Tomcat and this and that. What's next? Like, can I just skip this phase? Kubernetes looks hard. What if I just go beyond Kubernetes? What's after that? So have a look. There's stuff there. We can have a play with it now. I'm hoping there's a lot more options in this space for you to look at in the future. And come along to Next, and maybe you'll be surprised. Cool. Thank you very much. Oh, thank you. Now, you know how in YouTube, if somebody's speaking too slow, you can up the... Don't do that with me. Is it possible to integrate existing services with cloud functions using gRPC? Look, it's essentially a... you can. What it's triggering off of is a pub/sub event, a Google Cloud Storage change, or I think you can schedule events now as well. So what you do with gRPC is you write something onto pub/sub, or you write something into GCS and then trigger off that. So you wouldn't integrate directly in it. When will Cloud Functions natively support Golang? Oh, that would be good, wouldn't it? So what I can say is Cloud Functions is going to be in GA soon. And that's going to be in more regions and have more capabilities, but I can't answer that question. What software testing tool would you recommend for a DevOps environment? Have a look at Spinnaker and its integrations. At the end of the day, what I hear from a lot of people is, we've got this great DevOps team and this great thing, but look at all this testing is still manual. How do we have a look at that? And I think it's because of the complexity of the delivery and the deployment. And so what you need to look at is tools like Spinnaker and the integrations into the testing frameworks. Now try to tell us how to migrate an enterprise to the cloud. Bring it on. That'd be good. But I think our view has been that we're headed towards open hybrid cloud. So you remember that Elizabeth was talking about that big, awful bubble when you go to hybrid? That's sort of where I think the world is headed. And the reason I think it's headed is, yes, you can have a copy of my slides, is when we, people won't give up their data centers, right? People want control, and there's certain kinds of data that you want to own. So we don't want you to move everything into our cloud, as nice as that would be from a revenue perspective. I think there's a happy medium where this stuff is on-prem and this stuff's running over on the cloud. I think you can never get away from owning your own critical operations. And the more core it is to your business, the more sense it makes to have that core system on-prem, which is not to say that we should be patching hardware and machines. So I would be looking for more systems that make that side of your life easier on-prem, if you make sense. I've still got 3 minutes. I blew it. I know you don't like I like Microsoft. They're cool. I really like Satyam. I think he's doing an awesome job for Microsoft, and they're innovating, and they're doing lots and lots of cool stuff, and they're even embracing open source. What I don't like is they're still closed around .NET and systems like that. So, you know, I think if they were to embrace, and they are, you know, more of the Linux, more of the open source side, you know, watch out the world, Microsoft's coming back. But I've got a lot more respect for Microsoft than other cloud providers. With recent Facebook data breaches saga, how Google Cloud treats data stored in the cloud. This is really easy. You go to cloud.google.com/security, and there are a ton of white papers there around how we do encryption by default in storage and in transit. In other cloud providers, you have to turn that on. The other thing is Google is a zero trust environment. If you breach one machine, that's very good. Now try and breach the next, right? So everything from, you know, the custom physical hardware with cryptographic proof of identity, kernel cryptographic proof, operating system cryptographic proof, signed source code, you know, you're in a big battle to get past just one machine. The most common thing that happens when a machine does get compromised is it becomes a Bitcoin mining operation. Because it's the only thing you can do is call out if the firewall rules haven't been enforced. What are the main challenges you encountered with the self-driving balloons, drones, and cars? So regulation would be the answer to that question, and that's something we will work deliberately and thoughtfully with governments to work through. So in some jurisdictions, we've gone to the regulator and said, you know, what's the approval process? Oh, it's manual and it takes, you know, 15 weeks. We said, well, you know, can we put some eng on it and turn that into a 15-second API call? And you still get all the regulation you want, but we're automating the process. So you still get to do the approval through that. So there's other things like how we engage with governments around what they believe the future of the world is going to look like and what they need from us to make that future come true. So if you saw the news a couple of nights ago, there was a story about how, you know, the self-driving car is the path towards zero, and that's the kind of policy alignment we need. You want TAC saying we want to go towards zero. I drove back from a talk in Geelong the other day, and I'd driven an hour and a half down to Geelong, and I'd spoken, and you get a massive adrenaline rush when you speak, and then I crash, and I was going towards my car, and I was going, I probably shouldn't be driving home. So, you know, I've about 4 or 5 times recently, I've thought, I wish I had a self-driving car, because I don't trust myself to drive the next hour on this road, let alone if I decided to go to a bar after that talk and have a drink, and just one drink, and then get into my car. It's much safer if I wasn't behind the wheel, right? So I'm all for it. Our role to security architecture, it's everything. Like, I'm an ex-security architect, and you never stop being a security architect. If you weren't paying attention, go get the video of Elizabeth's talk earlier. It is absolutely critical that you get security right. This is, just look at what's gone on with Facebook. They do a fairly good job of security, but look, they can still be data stripped, data mined, and you've got to be constantly on your guard. I mean, as soon as you get into a public-facing role, you're under attack all the time. So security is vital. Go read the Google papers on security, the white papers, cloud.google.com.